Morning, everybody. David Shapiro here with another early morning update. Let's see. We have been working on. Oh, actually, here, let me cancel Flux real quick. Okay. There we go. Okay, so this is Cognitive Architecture Research Update. Um, I have added to the diagram because there's another microservice that I need, which is the embedding microservice. So I've introduced the Nexus, which is here. It's publicly available, and I've done a little bit of updates on the Nexus. So the Nexus is the core, the brain of artificial cognition. And then the conductor, this will be later on. I've also done research on the core objective functions, but then I started working on a simulation microservice, and we'll get into that in just a second. But then also an embedding microservice, which I wrote a while back using Google's Universal Sentence Encoder because it is fast and free. Okay, so first let me just show you, get you up to speed. I did a couple things to fix the simulation service. So let me just zoom in here. So what I did was, this is the same load last scene, generate an event given a backstory and a scene. So generate an event, then you generate a new scene, and then you save it, and then you summarize the backstory, including the new scene, and then it repeats. So let me show you what that looks like. I've got an example here. So given the following scene and event, write a new scene. So backstory, this was running the example. So it invented the men were playing, one loses, he practices obsessively. So this was the original scene, and then here's the event. The man who lost the chess game to the other man quickly defeats him the next time they play, taking his revenge. So then here's the new scene that it generates. The man who won the game is shocked and he can't believe that he was beaten, etc., etc. So you can see it's much more coherent now. So the two things that I did was I changed it from world state to scene, and then I added the backstory, which just takes all of this, the scene, event, and the new scene, and summarizes it. Um, and so that it'll recursively summarize it so that the most recent information is going to be the most reliable information or the most complete. And then the older the information is, the more concisely it will be summarized. So, it's just a few basic scenes. Given the following scene and event, write a new scene. Write a concise summary of the following, and then given the following scene, imagine a rarity event. So I have this so you can swap this out. So you can say like likely, rare, extremely rare, or dangerous event, or whatever. So you can modify it. Describe the event in one or two sentences. So you give it the backstory, you give it the current scene, and then it generates an event. Those three prompts, we've got a text-based simulation. I'm working on putting it together as a microservice. And so if we go back to this, instead of vision, we'll call it simulation. So it'll be the simulation microservice. Let's make this a little bit bigger. Simulation. I'm being OCD about this. There we go. Simulation. Okay. So the simulation microservice is going to feed stuff into the Nexus, but it's also going to read stuff back out because eventually what's going to happen is the output will be in the Nexus, and so then the simulation will need to be aware of what our agent is doing. Which, here's the agent, so that's like, what am I capable of? There's a whole bunch of other services. This is going to be like a big radial spoke thing before too long. So you've seen what the simulation does, blah blah blah, etc., etc. Okay, so we've got the simulation. I've got to just code all this up into finish the microservice. Now you see I've got a whole bunch of functions here. So these are all the microservice functions. So I've got Nexus send, Nexus search, Nexus bound, and Nexus save. There's a fourth function actually, which is fetch. So these are all functions that I've added into the Nexus service. So the first one is add, which is it's a super simple, you send a message, it gets registered in the Nexus and stored with a vector so you can search later. So the second function is search, required, vector, field, count, etc. What this does is you send it a vector and you say, give me all memories that are relevant to this vector. We're going to assume, I might just remove the field because we're just going to assume that everything is going to be in the vector or in a field named vector. So I'll probably remove that just to simplify it. And then so this returns a list of all the most similar memories. Uh, which is so the reason that this is because human memory is associative. So like let's say you've got a memory that you're like playing chess, for instance, in this example. So you want to look for things that like, okay, what was the, give me all the memories that we have of, playing chess and revenge and stuff. And so you immediately pull all relevant memories to whatever's going on. And then you can then use that to construct or reconstruct memories rather, and then that will also speak to your current situation. Now, associative memory is one of the primary ways that humans also rapidly generalize, right? Because deep learning, or what is the term? I don't remember. But like if knowledge and skills become deeply embedded in your mind so that you can just use it intuitively, you don't need to think about it. That's one kind of learning, right? And that is the kind of learning that happens from deep learning, transfer learning, fine tuning, where it's so deeply embedded you don't need to think about it. But we also need to have an agent that is capable of thinking and say, okay, I don't know, I don't have an intuitive model of how to do this, but I need to think through this. And that is where associative memory is critical. Now, the other thing other than associative memory is temporal memory, which is what the bound function is for. So this allows you to say, okay, I've got a specific memory that I've zoomed in on. Now give me everything in a window, like the last 60 seconds and the next 60 seconds, or give me an hour's worth of memories around this critical event so that I can fully understand and reconstruct what happened. So those are the two search methods, is associative and temporal. Now I've also got fetch, which says, okay, give me all memories that have a field with a specific value. So this will be required because when you're dealing with the microservices, you have every service that contributes to the Nexus is going to have a service name that registers. This will be really critical, especially for the conductor. So the conductor will need to be able to say who is talking here. So the conductor will need to ask the Nexus, give me everything that the core objective function service is doing. And so then the conductor can say, hey, core objective function service, you're acting up. Or let's say that the core objective functions are trying to train themselves better. So they'll ask the Nexus, hey, give me everything that the agent and output and input has given so that I can look at these past events and come up with better predictions for the future, that sort of thing. So you need to be able to not just search for associative memories, but say, give me everything relevant to this particular service or a particular UUID. So for the Nexus send function, I have this function. It'll handle the time. So it'll put a timestamp on when the memory is sent. It'll add a UUID so that every memory has a universally unique identifier. It will also add the prefix to the content, so that in the message payload you've got just a little bit of context as to what this memory log is, right? Because if you look at any log files, there's going to be a lot of stuff at the beginning saying, like, to give you a little bit of context of like where the log came from, what is the purpose of the log. And so the prefix is just going to be in every message that the simulation sends. So it'll be sensory input scene is this one. So that way in the Nexus, when other services are looking at those memories, it says, oh, this is an input thing. I know what this is. Or this is my agent model. This is so I understand what I am doing. So on and so forth. Or output, it says this is an action that I'm taking on the world. So that'll add just a little bit of natural language context to it. And also one thing that you'll notice is that we're basically getting to an abstract layer of programming where instead of everything being deterministic and functional, most of the decisions are going to be based on natural language. And you're going to be blown away by this because this is an entirely new paradigm of programming. And this is what I mean by artificial cognition. Anyways, the payload for the Nexus send, you add the time, the UUID, the content, the vector. So this is I had to go resurrect another microservice that I worked on. So I used to call it the use microservice, but that's not very clear as to what it does. So it's the semantic embedding microservice. Google Universal Sentence Encoder. You can do this with OpenAI now, but Universal Sentence Encoder is both very fast and free. And it runs perfectly fine locally on my CPU. Let me actually show you what this does. Okay, it's still running. And so um, I have a client that'll just send a couple of things. And look how fast that was. 0.03 seconds to get three semantic embeddings that are 512 dimensions each. So that's stupid fast, and that's faster than OpenAI right now. So that's all that this service does, the embedding service. And so you can see that here. It's also very short. This is the smallest microservice you'll ever use. So all it does is it loads Universal Sentence Encoder Large version 5. It's about 100 times faster than version 4, and it produces vectors of the same size. Basically, you send this microservice a list of strings, and it'll send back a list of vectors and strings. One thing that's fun is that they are what am I trying to say? They're JSON ready. So one thing is that NumPy arrays are not JSON serializable. And so what I do is I just go ahead and render it out to a NumPy string, to a list, to a string. And so then you have a JSON object that contains a string, and you can see what it looks like here. So you've got, the object here where it's a string, and actually, since it's a list, I might be able to take that out. I'll do some experimentation because JSON can handle a list of numbers. So I might be able to save a step and save some processing. Go back to the drawing board. Anyways, so it returns a list of dictionaries that has just the string and vector pairing, and that's it. And so that's all you need. Actually, yeah, I can probably take that out. Yeah. Yeah. Anyways, okay, so I'll just do this one little thing. Actually, that's going to break a whole bunch of other stuff. I'll go clean it all up later. Okay, where was I? I think that's actually about it. So there's 3 microservices that I'm working on. The Nexus, that was the first one. I gave a demonstration of how this does search earlier. So one thing is by switching to 512 dimension vectors, these memories are very short. So like if you look at each of these sections, it's just a few sentences, right? We don't need a vector that is larger than this in order to do search, because this is very, very soft search. Later on, when we have more powerful machines, better compression, and so on, yeah, we can use a 10,000 dimension vector for every memory. But right now, the vectors are going to be larger than this, right? So you see this selection that I have? This selection is 1,000 bytes, right? But then if you go here, this is 512 32-bit floating point numbers. So that's roughly the same size in memory, I think. Yeah. So there you have it. I think that's a complete enough update. I'm running out of time anyways. Let's see, time check, 13 minutes. Yeah, so just wanted to point out all this is publicly available. I'll make sure to do a git push and commit. But yeah, here's the Nexus, which is the beating heart, the memory, which is here. You can see this. So this is the central point for artificial cognition, which is why I started there. And second is the sensor input, which is here, the simulation. So in this case, it's running a scene-based simulation, text simulation that will push, that'll give our agent a virtual environment to work on. And then supporting all this is the semantic embedding microservice. So there you have it. Thanks for watching. Like and subscribe, and consider supporting me on Patreon. Thanks for watching.